Let's continue on with our in-class review problems for the Unit 4 test. Okay, we've got two sets of data here, and they show the fictional ages of students enrolled in two contemporary math sections. Okay, so I just made up a bunch of stuff. All right, now I've got the AM class and the PM class, and we'll take it one at a time. I would recommend, if you're struggling with this, that you will walk through this one, and then you try this one on your own, and just to make sure that you know how to do it. Okay, now the one thing that I will tell you on here is that to save time, I put these in order for you. But in order to find the lower quartile, the median, the upper quartile, and the largest value, they have to be in order. So I would put a note up here that the data must be in order, small to large, in order to find these values. If they're not in order, you can still find the mean, the range and the mode. All of this, other than the mean, they really need to be in order for you to find. Okay, well, we know what the range is. We know that the range is the high minus the low. So in this situation is going to be 45 minus 16, which gives us 29. That means the variation, there's a variation of 29 between the high and the low. So that goes with variation. The mode is most often. MO, most often. And you can see that the data value that occurs most often is 20. The mean is going to be the total divided by the number of students. And if I add all these up, or look at these, there are 18 students. So again, to save time, I'm going to give you the answer, but you will probably want to go and practice it on your own. So if I add up 16 plus 17 plus 17, and if a number is repeated, you have to add it twice or 3 times or whatever. You get 23.9. Okay, we already talked about the low and the high. So, you know, if you're given a bunch of blanks like this to fill out, then you can do it in any order that you want. Now, the median is the middle. Since there are 18 values, you're going to count in. So, count in. And so your median is going to be the average of these two. So it is going to be 20 plus 22 divided by 2, which gives us 21. Okay, then the only thing left is the upper and lower quartile. And that is the middle of the upper half. Oops, of the lower half, excuse me. And the middle of the upper half. Okay. So I look here, my median is 21. And I do not include it. It is not included when you're doing the quartiles. So I count in from here to find my lower quartile. And my lower quartile is 18. I do the same thing over here, and I get 1, 2, 3, is 30. Okay. All right, I'm going to go through it a little bit more quickly on here for the PM class. And again, if you have, you might want to pause and do it yourself and check your answers. There are 17 students here. Okay, so if I count in, well, and again, you can do this in any range. The largest value is 38. The lowest value is 22. So the range is 38 minus 22, which is 16. The median, since there's 17 students, there's going to be a single value in the middle. And when I count in, my median is 30. The value that occurs most often, let's see here, is 32. Now to find the upper and lower quartiles, I'm going to not include the median. So let's see here, if I count in, my median here is going to be the average. So 32 plus 32 is going to be, the average of those is still 30, whoops, and that's still upper, is 32. If I go in here, the average of 24 and 26 is 25. So I'm going to average those. Okay, now the mean, I'm just going to add them all up and divide by 17, and when I do that, I get 29.5. Okay. All right, so now we want to create a box plot for the data from both classes, and we want to remember to scale our axis. So if we're going to put both of them on here, then we need to be able to look at both sets of data. So my smallest of all the data values is 16, and the largest is 45. So I'm going to scale it and go from up to 50, and that should cover everything. So I'm going to start out with 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Okay, so I'm going to do the AM class first. Okay, and I can see all my values up here from the AM class. Okay, so the low value is 16, so I put a vertical mark there. The lower quartile is 18, so I'll put a mark there. The median is 21, so I'll put a mark there. The upper quartile is 30, and my maximum or my largest value is 45. And put a box around those in the middle and connect with whiskers to the ends. So this is your lower quartile, median, upper quartile, and high. Okay, we're going to do the same thing here for the PM class. So our smallest value is 22. Oh, that's way over here. Our lower quartile is 425. Our median is 30. Our upper quartile is 32. And our largest value is 38. So again, a box, around the values in the middle and whiskers to the ends. Okay. All right, now just some things that you can look at here. Clearly you've got an outlier here because you've got this long whisker. This class has a higher variation than this class. these whiskers are about the same, so this is a little bit more symmetric. This, if you have an outlier, it is going to skew it that direction. Okay, so just thinking about that, let's answer the question. We may already have done that. Which one has the highest variation? The one, if they're on scaled the same. So it's the AM. Which one has an oh, we already answered that. The AM. How does the outlier affect the mean and the median? Okay, so we talked about this. It doesn't affect the median much, but it is included in calculating the mean, so it has a greater impact. On the mean. Okay. All right, let's see where we're at now. Okay, we're down to the last part of it, which is all about the normal distribution curve. Okay. All right, so let's see what we're going to do here. We've got a normal distribution, and remember, all of this only works if it says it is normally distributed. The normal distribution is key. We have to say that. That means it is symmetric. This in the middle is the mean, the median, and the mode. The typical value is not the median, it is the mean. But since the mean, the median, and the mode are all the same thing. Okay. And then what comes out from here, this is our mean. And then each of these marks outside, this is plus 1 standard deviation, plus 2 standard deviations, plus 3 standard deviations. This is minus 1, minus 2, and minus 3. The other thing of note from the mean here, %50 of your data is to the right and 50% is to the left. And what you need to know is the 68, 95, 99.7 rule. So what does that mean? That means that 68% of the data is in between 1 standard deviation. So from here to here is 68% of the data. 95% of the data is in between 2 standard deviations. And finally, 99.7% is in between plus or minus 3 standard deviations. So in between here and here, 95% of the data points are in here. Between here and here, 99.7%. Now, why is this 50% important? Because if all of this is 68% in between positive and negative 1 standard deviation, that means half of it is here, half of it is here. So this is 34 and this is 34. And I would suggest that you go back over those little charts that we did in 6C and read and watch the videos if you need more on that. Okay, now I don't know why I did it like this, but it's going to ask you, you're going to have to find all these values. Okay, so we can just mark them on the graph. I think that would probably be easier. Again, I'm not quite sure what I did here. Okay, so 1 standard deviation, we know that our mean is 75. So that goes smack dab here in the middle. Okay. One standard deviation, the standard deviation is 4. So that means I add 4 to get 79, subtract 4 to get 71. So that is one standard deviation. To get 2 standard deviations, I add 4 again and I get 83, subtract 4 again and I get 67. And then for 3 standard deviations, I add 4 again and I get 87, subtract 4 again and I get 63. Okay, so those are all the values that you need. Okay, so let's answer some questions about this. Oh, what percentage of values lie between C and E? Well, C and E is 1 standard deviation, and that tells you that it's 68% are in between there, between C and E. So if you were to do this, and I'm going to mark this up and it's going to turn pretty ugly here, but I'm going to go ahead and do it. So between C and E, between -1 and +1 standard deviation, that is 68% of the data. Okay. What percent of data lies above D? Okay, so we already know that since this is symmetric and since D is the mean, it is 50% above and 50% below. Let me do this so we can see more of it. Let me autofocus again real quickly. Okay, there we go. Maybe that'll be easier for us. Okay, what percent lies below E? Okay, well, let's see what we've got. Now, I'm going to split this up. And from to the left of D, just like here, I know that from here all the way to the end is 50%. But I want to know from E down. Well, I also know that from D to E is half of the 68%, which is 34%. So if I'm looking at this, and what I'm really looking at here is from this value all the way over, it's going to be the 50 plus the 34, which is 84%. Okay, let's find the standard deviation of 68 miles per hour. Okay, so 68 miles per hour is going to be it will be right here. So 68 miles an hour is going to be right here. And I want to find the standard deviation, which is the same thing. The standard deviation is the same thing as find the z-score. And there's a formula for that. Okay. So the z, and you will be given the formula. The z-score is the data value minus the mean divided by the standard deviation. Well, we have all of these. So I can find the z-score. The data value is 68. The mean is 75. And I divide that by the standard deviation, which is 4. Now, oh, and I'm sorry, you can't see that. Okay, but now what I want to do is I want to think about what it should be. 68 is between -1 and -2 standard deviations. So as I'm thinking this, it should be between -2 and -1. Well, if I do this calculation, this becomes -7/4, which is -1.75. So that checks out. Okay. All right, so find the speed if the z-score is 3.2. Well, what we're looking for here, if I'm asking to find the speed, what I'm really asking for here is a data value. And again, we have a formula for that. We know that the data value is equal to the z-score times the standard deviation minus the mean. Okay, now the other thing I want to do is think about where it should be. If the standard deviation is 3.2, this is going to be somewhere right here. The standard deviation is 3.2 because this is 3. So I'm going to say that it has to be greater than 87. I'm going to say 88 to 90. I've got my z-score, I've got my standard deviation, I have my mean. Okay, so my data value is going to be equal to my z-score, which is 3.2, times my standard deviation, which they gave me in the problem, is 4, and then I'm going to subtract the mean. And when I do that, I get 87.8. And that's where it should be. Okay. Let's see, we did some other things. So we may just go ahead and do a couple more of those. Trying to find the ones that we did. Okay, let me get a piece of paper. I should have typed it up. I should have redone this whole thing for you guys, but I didn't, so anyway, that's okay. Okay, so we're going to continue to use this chart. Okay, so I'm going to ask what percent of people drive 85 miles per hour or below. What percent, this is asking for the percentile. So if we do that, we have to go to our percentile table, which, let's see, I'll be digging that out while I talk. That will be given to you. And, but what you're going to have to do is to find the percentile. What you're first going to have to do is There's going to be a two-step process. So one, you're going to have to find the z-score for 85 miles per hour. And then you're going to use that z-score to find the percentile on the table. Let me see if I can find, well, it doesn't matter. Okay, so find the z-score. We have a formula for that. So the z-score is equal to the data value minus the mean, and these formulas will be given to you, divided by the standard deviation. The data value is 85. The mean is 75. The standard deviation is 4. And that gives us 2.5. Okay, now once again, I'm going to go to my graph and see if that makes sense. It does. 85 is right in here, so my standard deviation should be between 2 and 3. Okay, so I found my z-score. Now I am going to go to my table and find the percentile on here. So if I have a z-score of 2.5 on my table, my percentile, so the percentile is 99.3, I think it's 38. And that's what the percentile means. 99.38% of people drive 85 miles per hour or less. All right, and I think I'm going to ask one more question about this before we move on. I'll just do this here. And what percent of data is below B? Okay, so here is B. And there are a couple of ways that we can do this. Okay, and I'm just going to draw a couple of real quick drawings here so you can see what's going on, and you can do it either way that you want. Okay. We know that B is two standard deviations, correct? And E is it E that's the other one? No, F. B and F. This is the 2 standard deviation mark. And then, of course, right here in the middle, we have our mean. So this will be the same on both of these. Again, there's just a couple of ways to look at this. This is our 2 standard deviations. So what we know is that since this is 2 standard deviations, means that between B and F is 95% of the data. So that's 95% of the data between B and F. But what we want is below B, so everything below B. So depending on how you look at it, you can say, all right, well, I know below the mean is 50%. I know this in here is 95 divided by 2, so this is 47.5%. So I know below B is 50% minus the 47.5%, which is 2.5%. Now the other way to look at it is that I know since B is 95%, outside B to F is 100 minus 95, or 5%. So that 5% is below B, less than B, and greater than F. So below B is half of 5%, which is 2.5%. So again, you can do it either way. I'm wondering if I should do this last one. I think we've covered one of everything and a couple of extras, so I think I won't do this last one. And but I think you'll be okay. We did it. It's almost identical to this last one. Actually, I think what I'll do, let me take that back, is, I'm sorry, I'm just kind of thinking out loud. I'm going to go ahead and put the answers on here, and then so you can use that as extra practice if you choose to. Okay, so this is about a house, about housing in Round Rock. Okay, and of course I can't find my notes on that. So let's find this real quickly. All right, so this is housing in Round Rock. Okay, and it is normally distributed with a mean of 300,000 and a standard deviation of 50. Okay, so we've got our mean of 300,000. I'm going to have to do this sideways. And a standard deviation of 50,000. And I've got my 68, 95, 99.7 rule. I know that within one standard deviation, 68% of the data. So between 350 and 250, 68% of the houses are between there. 95 is plus or minus 2 standard deviations, so 400,000 and 200,000. And then finally, 3 standard deviations is 99.7, so this is 450, and this is 150. Okay. All right, so that answers all of those real quickly. We were able to label all those, and we know what they are. Okay, so, and again, I'll label them just on the right, and then I need to save a little time. This is 1 standard deviation, 2 standard deviations, oops, that's a 2, and finally 3 standard deviations. And then, of course, there's a little data outside. Okay, between C and E, that's 1 standard deviation, so that is going to be 68%. Below D, this is the median, which means half is to the left. half is to the right. So below 300,000 is 50%. Above E, now we already talked about this, okay, above E, I know this is half of 68, so that's 34. So this is going to be, above E is going to be 50% minus the 34%. So that's going to give us 16%. Okay, find the standard deviation if it's valued at 410. Okay, 410 is going to be right here, which means my standard deviation should be 2 to 3. So all I have to do is plug this into my formula, which is my data value, which is 410, minus the mean, which is 300,000, and take all that and divide it by my standard deviation, which is 50, and that gives me a standard deviation, or a z-score, of 2.2, which is exactly what I thought. What is the value if the z-score is negative 1.4? Okay, well, negative 1.4 is going to be somewhere in here. Z equals negative 1.4, so it's going to be between 200 and 250,000. Okay, so there's one for that too. What is the z-score, or what is the value is equal to the z-score times the standard deviation plus the mean. Oh, and the standard, I'm still on the last problem. The standard deviation here is 50,000. Sorry about that. And when I do that, I get that it is 230,000. And it's right where it should be. And we added one more question here, and again, I will do this very, very quickly. What percent of people live in houses valued at 370,000 or less? Okay, so that's asking for a percentile, so this is going to be a two-step. So number one, we have to find the z-score. We have a formula for that, so it's going to be our data value minus our mean, all divided by the standard deviation, which gives us 1.4. Now, before I go and see if I've made a mistake, I want to see. 370,000 is going to be right here somewhere. And it should be between 1 and 2 standard deviations. In fact, it is. Okay. Now that I have a z-score, find the percentile from the table. And if I have my table, if I'm looking at a z-score of 1.4, it is 91.92%. And that is that 91.92% live in houses valued at 370,000 or less. Okay, the end.